Hey, good evening, everyone. I don't know if anyone has a step, so I can look a little bit taller here. But yeah, so today I'm very excited to be here to share some of the recent research I did on malvertising campaign. So to give you some background on me, so I'm a senior security researcher, part of the global research and analysis team at Kaspersky. And basically, the focus of our team is to do research on APTs and crimeware threats. And this presentation is a result of one of those researches. So I'd like to start with a quick question. A show of hands if you have ever willingly or unwillingly clicked an ad you saw in a website or on a Google search engine, something like that. I certainly have, unwillingly, and the potential for bad things to happen is quite interesting. So let's get into it. So what would we talk about today? So I'll start with a quick overview of what is malvertising and how it works, so we're all on the same page of what our understanding of it is. Then we'll move on to how we discovered this campaign, so this will give you a more temporal context of things, as well as technical analysis of it. And then we'll talk a little bit about the threat actor and their infrastructure. So we'll focus more on the infrastructure side, and specifically how they ended up exposing some interesting information about their victims. We'll then discuss some of the campaign details, so this will basically build on the previous two sections, knowing how the infection chain works and how their infrastructure is set up. We can assume some of their campaign numbers. And then we'll finally just close with some considerations about malvertising, and I'll leave some open questions for you to consider, and then any questions you might have about the presentation. So what is malvertising? So malvertising is a portmanteau for malicious advertising, and I learned about this word recently, so I wanted to share it with you. So in a broad sense, it's basically the use of online advertising to spread malware. The first references I found about malvertising date back to 2007. So those were basically the good old days of shockwave flash, where basically every website was a potential RCE vector. And what makes malvertising interesting from an attacker's perspective is that the distribution is handled by a legitimate third party. So basically this means that when you want to distribute some malware, you basically just buy some ad space on some engine or whatever, and then you push it out to very customizable targets. So this for the attacker is very good because it offloads all of the distribution to someone else. And also is very annoying for the researchers. For the attackers, it's basically free real estate because they can get visibility in very high-profile websites, and it's very easy for them to hide because as soon as they just turn off the ads from showing, the distribution is gone, and you're left in the dust. So this makes it hard for the researchers. First, you need to know what kind of targets they're after, so you're able to either search the same keywords they're after. And from this presentation, you'll also see that the infection chain can be built in such a way that the malware only detonates if it knows it came from an ad being clicked by a victim. So quick how it works. So the regular kill chain is very easy. So a user searches for some keyword, they're presented with an ad that matches the search, they click the ad, and they end up in a phishing website. So from here, the consequences will depend on the kind of attack that's going on. So it can be something like credential or data farming, it can be some kind of fake download website, or it can even be something very simple like some support scam, like tech support scam, stuff like that. So in the images here you can see, so the top image is just like a support scam where they don't even want you to click the ad, they just want you to call that number. And then you have the Obsidian and the Slack malvertising. So the Obsidian one, if you can read it from there, the actual URL is very suspicious. It doesn't have anything to do with Obsidian. But the Slack ads, so it says it's going to slack.com, but in reality it isn't. So just these images you're seeing here, these are from João Seguro, which is a researcher from Malwarebytes, and he does a lot of research into malvertising. So if you're interested in knowing what's going out there about all of these things, I would suggest you to follow him. So let's now move on to the specific campaign that we observed, so how we discovered it, and how the infection chain went. So this will be very straightforward and easy to follow. It's not very complicated. We'll just focus on the main logic, which will become handy for the analysis, for the campaign analysis that goes after. So the discovery. So basically, in April, we had a flag for a Trojan downloader for a file name that was named with the name notion.executable. So Notion is basically a utility application for taking notes and stuff like that. And it was also being hosted by a typo squatting domain. So we started looking at this in August, and that's where we found some references to domains related to malvertising based on João's work as well. We reached out to him and talked about it, and it was also during that time in August that we also found some other utilities being targeted, so like Slack, Discord, Zoom, and stuff like that. So quick TLDR of the infection chain that they were using. So basically the victim would search for the application, so it would be Notion, Slack, or whatever, and they're presented with an ad. The victim would click that ad and they would go through a redirection chain. So the purpose of this chain was to validate the user. So they wanted to know that when the victim reached their phishing websites, they came from clicking the ad. So if you visited the website without coming from the ad, it would show a different website. And once you're at the website, you would download a fake installer. This fake installer would then just basically set up some basic persistence and drop the final payload before actually even fetching the legit application and installing it on your computer. So with this in mind, we can now look at the more specific details of each of these steps. So from here, 1 to 3, so this was basically the flow you would see. So you would search, for example, Notion. You would be presented with something that looks like Notion. You would click it. You would end on an exact copy of the Notion website. And then when you download it, here you can see on the 3, you would end up with the binary. And the relevant point here is, so in the 3.1, you can see that there are actually 3 redirects before you end up on the website. So we believe, we're fairly certain that these redirects, besides being monitoring the ad clicks, they were also part of the user validation to make sure that the user, when he landed on the website, he was coming from the ad. And in the 3.2, when the user downloads a fake installer, we see 2 other URLs being served. So we believe that this is related to whitelisting the IP, and this will become relevant further down the line, because you will only be able to go through the entire chain if your IP was whitelisted. So here, I think you can see it all right. So here it's basically the first stage. So this is what the binary you downloaded had. So it was a fake installer, which was simply a .NET self-contained application. So basically this just includes the .NET runtime and libraries, which makes the application significantly large, so it's around 200 megabytes. The actual payload is just a very small DLL that was embedded in the application, and the single purpose of that DLL was to fetch the next stage. So again, to point out what's relevant here is that you would only be able to hit that URL and to fetch the next stage if your IP was whitelisted or if you provided a valid UUID. So this UUID we'll see next is part of the next chain, the next stage. So if your computer was already infected, you had a valid UUID, and you could also fetch the second stage without having a whitelisted IP. So the second stage, so basically is where we find all the logic. So here we have the diagram on the right is basically a representation of the image on the left. We can see that it has basically 4 logical blocks. The first block is basically to make sure the user is running the application as an administrator. So basically it will just loop calling run as and just showing the calling run as with the application that was just downloaded. Then you have a second block, which is basically a very simple evasion and persistence technique. So they would basically add the system drive to the Windows Defender exclusions. They would create an application backup in the local app data. So we would just create a folder name backup and place the application there. And then they would add that application as a task to the task schedule. So every time you would log on to the computer, this binary would be run. Then on the third block is where the interesting part happens. So this is where the script would check for the C2 if it was up and validate it, and then it would download both a key and an IV and a payload, which would then decrypt and run it. At the end of that, you can see there, it will send the UUID to another endpoint, just basically to validate so this UUID was infected, and this would be the final part of the dropping of the payload. And at the end, the last block, so like I was saying, they were nice enough to download the actual application and install it for you. What's interesting here to note is that they were very lazy, and I think you can read it on the code. So the function names, the URL, and the comments, they all mention different applications. So you can see they were actually targeting different applications, but they were just basically just quickly modifying the script and just pushing the script to the servers. And finally, so you have a final section in the diagram that says listen for server commands, and this is not present in this script, and that's because this was a functionality we observed maybe during a 2-week time period. I guess they were probably trying to add some other kind of functionality to this dropper to be able to fetch other files. We weren't able to get any commands from them, but we know that it was live during maybe 2 weeks, and then they take it off. They took it off from the script. So, and at the end of this, you would end up with a payload, a final implant on your computer. So basically, we've seen all of the payloads they were fetching, they were always encrypted with AES or an unknown cipher. So we weren't able to understand which cipher it was, and we believe that this was related to a similar but different infection chain, which has some other script. Although the things we were able to decrypt, we basically just did a quick validation on the families. We just wanted to be aware that they were dropping LumaStealer, SecTopRat, and Darkgate. Although the Darkgate, we're not 100% confident on the detections, but it's a possibility. And another thing is that they were quite consistent on the drops, so they weren't constantly changing the binaries. The binaries barely changed during this time period where we were analyzing the infection chain. So, moving on to the threat actors and their infrastructure. So the purpose of the following slides is to give you an overview of their infrastructure, and followed by how a screw-up on their side led us to some interesting logging files, which then provide us a way to measure the infections that they were having in that campaign. Okay, so in this overview, the point here is just to show you that from this very little amount of information, we were able to keep track of their activities. So sometimes this very little things go a long way. We saw that they were using a very small set of providers for their infrastructure. Interesting, we saw that the DLL that they were dropping always had one of 3 users. So I started calling them the 3 stooges. So basically it was either MPX, NVKL, and Dimitri. So, and interesting enough, this was more than enough to hunt for newer DLLs that were being pushed, because they always left this there. And also, interestingly enough, is that they had at least some segregation of stages. So we can say that the phishing website, you can call it like the first stage, and then the second stage, which is basically the C2s. They would never mix up infrastructure between them. We did see one phishing website, so one IP sharing 2 different phishing websites, and on the C2 side, we actually saw 7 different domains sharing the same IP. So the same stages, they were actually sharing infrastructure in between on themselves. So moving on to more interesting things about their infrastructure. So basically, exploring the infrastructure and trying to understand what was available. So not surprising, they were hosting the backend panels on the second stage infrastructure, so the C2s. We did not explore the panel itself. But what we did find, which was way more interesting, was that they had one server which probably was missing the index HTML file, so it was listing the root directory of their server. And from there, we found out they had some very interesting logging files available, which I will discuss next. Besides the logging files, you can see they had a file called safeip.php. So we are not sure about where it was being used. We imagined, based on the name, that was probably related to all of that user validation or IP validation, something like that. But since we had very interesting data from the log files, we just explored that. So the IP.txt file, so as you imagine, very straightforward. So basically, this was just a list of IPs. What we noticed is that the file had the IPs sorted, and after a huge amount of IPs, the IPs started becoming random. So what we believe that they were basically just copying the file between servers and probably just sorting the file to analyze something. We did notice as well that there were two very high hits for IP, so those 3,600 and 1,500 hits. So I would believe that maybe, and this is something that threat actors do, is they test their infrastructure a lot, so I wouldn't be surprised if one of those IPs could be related to their development phase, where they probably were testing the infrastructure, testing the deployment of the infection chain, and so on. So besides that, we don't have a very specific idea on the purpose of the file. So maybe it was to control the access to the phishing websites, maybe the access to the other stages. It could be like the infection telemetry, although the number of unique IPs we saw was a little bit too high for it to be actual infection telemetry. And next we have the UUIDs files. So this is very similar to the IPs files in the sense they just kept a record of the UUIDs. So we consider that this might be either keeping track of the requests coming from the endpoints that receive a UUID, or if you remember back to the diagram where they would send a post request with the UUID, this could be, for example, a place where they would just register that UUID as someone that just was infected. So given the difference in numbers from this file, so 1,700 to 17K from the other file, so we might believe that these could be related to somewhat different infection chains that we did not have visibility onto. And actually, at some point, we did see one of the C2s providing a second stage script that was not sending the UUID of the infected machine. So it could explain the discrepancy we see between the numbers of the IPs and UUIDs. So moving on to some more interesting files. So one of them was the access log. So this basically showed timestamps and either the access for a given IP was approved or denied. We saw that there were a lot more approved IPs than denied. Again, we are not sure about the purpose of this file because a lot of IPs were approved. Maybe it's related to some kind of access validation to the script, the phishing website, or something similar. And now, so this is one version of the most interesting file we found. So the access.txt file is basically, again, it shows the timestamps and also shows access denied or allowed or approved for a given IP. So this was most likely, and here we are fairly confident that this was highly connected to the infection chain, although we cannot discard being related to something else. But based on, they always had the same pattern of a given IP would always show access allowed get code and then access approve IP. So this was very interesting, but this doesn't fit the infection chain that we saw. But there was another version of the access.txt file, which was very promising. So basically, this version was clearly connected to our infection chain. We can see that because they were referencing the 2.php and the 3.php files, and they also had a very specific pattern, which was you have access allowed followed by 2.php followed by 3.php. So a given IP would always follow this pattern, and basically where you see not provided on the top. So this basically, we assume this means it's a new infection because the computer does not have the UUID file written to disk yet. So the IP has to be whitelisted for they to be able to reach 2 and 3 PHP. Otherwise, the system would just say access denied. So this was basically the most interesting thing and gave us a very good potential to be used to get some accurate numbers on how their campaign was going, which is what we are going to look at next. So now that we know about the logic of the infection, so we know the exact steps that the infection chain takes, we have access to the logs from the C2s that apparently show very promising information. We can now put that together to try to derive some telemetry information. So the next slides will focus pretty much on that. We'll start by taking a quick look at the timeline of the domains when they were used to give a better temporal context. And then we'll define the methodology we use to measure the infections and the outcome of those. And so before moving on to the next slide, I just want to apologize for the messiness of this next slide, which is this. So bear with me. So this is a snippet of the phishing domains as well as the C2 domains that we were aware of. So to describe the image, so on the middle you can see the timeline. So this is for the current year between April and mid-November. Everything that's above the line are the phishing domains, and everything that's below the line are the C2 domains. So the length of a line for a given domain represents when we know that domain was active, and so they had the DNS record that was active for the campaign. It doesn't mean it was like it was taken down or something and pointing to somewhere else, so we know that during that time it was actually active. So another thing to point out is even though you might see this different domains on the same line, so that doesn't have any specific meaning. It's just a way to make sure I could fit more things into the image. So if we look at the length of the phishing domains, we can see that they're active for a smaller time period than the C2 domains. So it means that most likely the same C2 domain was being used between different phishing domains. And one other interesting thing is that you can note that currently, so on the bottom of the image, there are a lot of domains that appear to still be active, and they're not. So what happens is, although the IP is the same IP that was serving the C2s, when we try to connect to it, it accepts the connections, but it doesn't return anything. So at first, we thought maybe they were using these IPs as some kind of reverse proxies for some other backends, but this doesn't fit into the things we had from the log files, because different domains had different log files, so most likely they were actually different servers, so the reverse proxy idea does not hold for this. We know exactly how to explain this behavior, so something interesting to consider. So with this being said, so what we did is, so basically all of those bottom domains, we collected the logs that we could from them to be able to use it as telemetry and to mine the telemetry. So how did we approach this? So going back to the file contents, you can see, so we have block 1 and block 2, those square in green. What we did is we concatenated all the access.txt files and then we dropped the timestamp. We dropped all the duplicates, which it doesn't have any meaning duplicate lines because they have timestamps. So if it's the exact same line, it doesn't have any relevant meaning. And since the files were being moved between servers, and we observed this because files on different servers would have the exact same beginning lines, and then if an older server stopped being used, you would see that the newer server would have more lines in it. And then basically what we did to measure, we basically assumed that, okay, so if we see an entry for a given IP, and then that IP hits 2.php followed by 3.php, and there's no UUID given, we assume that's a new infection, and we have some confidence that it's new and it's legit because the IP, again, the IP has to be whitelisted for it to be able to reach 2 and 3.php. The other case would be that if we saw an IP hitting the 3 endpoints with a UUID, so we would assume this would be an already existing infection, and we wouldn't count it as a new infections. So basically, we're more focused on the new infections, and we pretty much discarded everything that was just checking in, with a bot just checking in. So based on this, so what the files we were able to obtain from 5 different domains. So this was between the 23rd of July and the 29th of October. So the numbers we observed based on that methodology was that we had a little over 3,000 unique IPs for that time period, spanning over 10,000 records. What's interesting, and you'll see on a graph further down, is that the average, this gives around 31 infections, new infections per day on average, but the median was 5 daily infections, which is interesting to say that there's such a different number between the average and the median for the new infections. Okay, so looking at this geo distribution, so this is all for unique IPs, and it's based on the access.txt file for that specific time period. So it's interesting that we see a big incidence in Europe, so it would be around 80% of the infections for unique IPs were coming from Europe. So on the table, those are basically the top 10 numbers for each country, and if there's only Australia and Canada that are not in Europe, all the other countries are part of Europe. So this kind of hints at what they were targeting, and again, so since they were using malvertising to distribute the malware, we can consider, okay, so they were actively targeting specific countries, which you can easily do on an ad. So again, so we can pin down, so even though they were targeting Slack, Notion, etc., we also know that they were also targeting these specific countries. Again, taking into consideration, this is a subset of their entire operation, I believe, because we were fairly certain that at this point that they had some other infection chain. So this is just a small set of everything they had. So take that with a grain of salt, but interesting numbers nonetheless. Okay, so about the timelines. So this is why it's that you saw that difference between the average and the median. So what we saw is when we measured the new infections, we see those spikes in July, August, and October, and those are quite huge spikes. So those are around over 400, both in August and October. And apart from August, where we see a healthy, and for lack of a better word, we see a healthy number of infections throughout the month. So we don't know, but maybe they wanted to invest on pushing ads during that period. And this, I even considered, so I don't know if you ever pushed an ad. So basically you can define how much you want to spend per day. I don't know if they didn't set a budget limit for daily ads for an ad to be shown, which could probably explain why they had a huge spike and then it normalizes. For example, after like the third bar, they would maybe set up, okay, so let's just spend like maybe 10 or 20 euros per day on ads, and which would explain why the long tail on the rest of the month. So again, the dead zones, we believe that it doesn't mean they weren't active. it means that probably they had that slightly different infection chain, because again, based on our methodology, we know that we were targeting that very specific file and counting the numbers from that very specific file. If I showed like the numbers for the 20,000, 17,000 IPs, I'm sure this would show a lot more hits. But again, so this is just a small subset of their operation. And so with this, I just wanted to close with that. So we looked at the campaign from these basically the three stooges, which most likely it can even be the same user with different usernames. Most likely, it doesn't have any specific meaning. We saw that 3,000 infections on that time span of 3 months, which seems quite a relevant number. We saw that it's a high incidence in Europe for that specific infection chain. We also believe that the TTPs most likely change, not only because we know that they have slightly different infection chains, but I stopped seeing activity on those log files, so I believe they might be moving on to something different. And again, this goes to show that malvertising as a distribution is quite interesting. So we just offload all the distribution efforts to someone else. We just pay a legitimate vendor, and so here's who I want to target, here's the country, what they are searching for. I mean, during this investigation, I tried to publish an ad to see, so it's very interesting the amount of customization you can have, and this is very good for the threat actors to be able to so easily access very specific victims. And if it wasn't for their screw up on the OPSEC sides, we probably wouldn't be able to have this information, because again, you would have to be able to know exactly what the ad wanted you to come from. Probably it was a referral or whatever, but you needed to know the exact steps to be able to go through the entire infection chain, which makes it harder to detect, because if you just send the fake installer to VirusTotal or whatever, it won't detonate. So, and it will probably, I'm not sure if it will even detect. Probably it will give some detection because it's fetching something from somewhere else. But again, you won't see what it's dropping, which is good for them because they want to hide their final payloads. So I don't know exactly what we can do about this. So I think this goes back to basics. So we humans are always the weakest link. So I think we should keep educating users on these vectors, which keep being using more and more. One might consider that ad blockers might be a first measure, a first blocking measure, although you're actively blocking actually a legitimate service, so it's debatable of if you should do it or not. There's also maybe some kind of work from the vendors that are selling the ad networks. So some of them already apply some measures to show they have initiatives like the transparency initiative, so where basically, I don't know if you ever noticed, but if you're shown an ad specifically on Google, you can actually see who is publishing that ad, and based on the publisher ID, you can go to the transparency site for the ads, and you can actually list all the ads from that specific publisher. So this gives you an understanding, and it's actually a good way to see, okay, so if this is a malvertising ad, let me search if this actor is pushing something else or whatever. And also, again, as I was trying to publish an ad, although I didn't do it because of ethical reasons, I did find out that they do some automatic validation. So if you try to publish an ad about that relates to finance, they block you. And basically the automation blocks you, and you have to manually say, yeah, just review my request. Which it will probably be blocked because it was a very obvious malvertising thing. So yeah. So I'll leave you with this. Thank you, everyone. I don't know if you have any questions. You can find me on X, Mastodon, or Blue Sky, whatever is your flavor. So yeah.